Let's talk about arrays in C++. Now, arrays are collections of data of a particular data type, right? And they can actually be thought of as a collection of variables. Now, the declaration of an array is of the following form. You start with the data type, followed by the identifier, and then within brackets, you have the size of an array, right? So let's take a real example. Here we have an array of type int. The name of the array is scores, and it is of size 5. So this gives us 5 array variables of type int, right? And these can be referred to as scores 0, scores 1, so on till scores 4, right? If you recall, we used a similar notation to access characters of a string. We use the bracket notation. But do note that string is not quite an array, but the bracket notation might look similar. Now, each of these things can be referred to as an indexed variable or an element of an array. The indexes start at 0 and they go all the way up to size minus 1, right? Size minus 1 because it starts at 0, right? Uh, the data type of an array is also referred to as the base type or the base data type, right? We can mix declaring variables with array variables. For example, in a line, we might have an int variable followed by an array variable, followed by another int variable that is initialized. Right? Now, index variables, such as the ones above, can be used anywhere variables can be used. So, for example, you can have them on the left side of an assignment or an expression on the right side of an assignment. That is perfectly fine. Now let's talk about more about using arrays. Now we've learned a few looping constructs. We've learned while, do while, and for. So which one is the best with arrays? And it turns out that the for loop is very naturally suited to stepping through elements of an array. And a typical pattern of using for loops with arrays looks like this. You have a for loop, you have a counter variable that you start at 0, and you increment it with every iteration. Now, the stopping condition is typically this, where you have the loop variable less than the size of the array. Note I'm using this function called size, which gives me the length of the array scores. Within the body, I'm doing something with the array using the indexed variable being indexed with I, right? So the same pattern can be used for other things, such as finding the maximum value in an array. The pattern would be very, very similar. The only difference here is we will need another variable called max score to keep the maximum value. Now let's assume that scores go from 0 to 100. We set max to a value that is low, that is below the minimum value that scores could ever be. And within the body of the for loop, we check whether we find a value that is higher than the current max, and then we capture it in max score. Right. Another example is one of getting the position of the minimum value in the array. So again, we keep a variable to track the minimum score. We set it to something beyond possible values of score. And then we use another variable here to capture the actual position. So in the body here, what we're doing is we're looking for values that are lower than the current min. And we capture it. And then we also capture the position of the minimum, right? Now, there's another variant of the for loop that is particularly useful for with arrays. It allows us to step through arrays without needing a counter variable like I up here. And it's called the for each loop, right? And the for each loop looks like the following. You have for, and you still have the parentheses. Within it, you declare a variable here, in this case, s, then you have a colon followed by the array variable. Now, and at each iteration, variable s is going to hold the next value in the array. right? So here, no need for the counter I, right? The only thing you have to note is the data type of this variable needs to be the same as the base data type of the array, right? Now, it is best practice to use constants in array declaration. Above, you notice that I'm using an actual literal, and that is typically not good practice. You do want to have a constant. So, in this case, what you might want is declare a variable called num and set it to your value, and that use that everywhere. That is appropriate. Now, in the lesson, I'll still be using literals for exposition purposes, but best practice is to use constants. Uh, Also note that arrays cannot be sized at runtime. So what do I mean by that? So you can't have a code like below. So here we're declaring a variable of data type int called n. Then we read input um, from the terminal and set the value of n, right? And then we use n in the declaration, right? And this is not allowed in most compilers. You might find compilers that let you get around it. And this is the reason it's not allowed is the value of n is determined at runtime, right? There are other ways to do this in C++ using a function called malloc, which won't be covered here. But typically you will get a compile time error here, uh, and sometimes even possibly a runtime error. Okay. Now, I did mention strings earlier. Strings that we bring in with include string are not arrays, although they look very much like arrays in usage in using the brackets. Um, and they are in fact something called class objects that we'll learn more about in future lessons.